Okay, we are going to look at problem number 23. So let's see what we got. We got this table. And let f be a function that is twice differentiable for all real numbers. The table above gives the values of f for the selected points on the closed interval 2 to 13. First thing we gotta do is estimate f prime of 4. So I want to estimate what is the derivative at 4, right? So what is the derivative? So I think you guys would agree 4 is going to be somewhere between 3 and 5. So I'm going to estimate, and the way I'm going to do that is I'm going to find the slope of the tangent line between those 2 points, and that will be about, right? That's going to be my estimate. So I'm going to say f, let's label this letter A. So f prime of 4 is about the slope between f of 3 and f of 5. So in this case, f of 5 is -2, and f of 3 is -4. And of course, 5 minus 3 is 2, so that gives us -6 divided by 2, which is -3. Okay, so again, I looked at the slope of the line from 3 to 5, and that slope I said was about, right? I'm using it to say that it's about, because I'm choosing the 2 closest points that surround 4. Okay, let's look at letter B. Evaluate the definite integral from 2 to 13 of that function. Show all your work that leads to the answer. Okie dokie, let's see what we can do. Okay, so first off, I'm going to break this up into 2 pieces because, well, I'll show you why. So the first piece is just going to be this, right? I know I can integrate 3. I know what that is. The second piece is going to be -5, which is a scalar. Whoops, I did drop something there. Let's fix that up a little bit before we continue. This was 5 times f prime of x. Let's fix that. So 5 is a scalar, and it's going to be multiplied by the antiderivative of this function. Okay, looks good so far. So we take the antiderivative of 3, we get 3x, and we're going to be evaluating that from 2 to 13. And this is going to be -5 times, so second fundamental theorem of calculus, f of 13, sorry, first fundamental theorem of calculus, not second. I keep on saying second fundamental theorem of calculus for all our problems. I just kind of got glued onto that one. But no, this is first fundamental theorem of calculus. Okay, so we've got that, and then I'm going to evaluate that second part, right? So again, if you're not sure, notice I used the flashcard in order to evaluate this, right? It wants to know what is the displacement, right? If that integral represents the displacement, and it wants to know what's the displacement or the change in the y values from 2 to 13, and that's what I'm doing there. Okay, let's finish letter B up. So what do we get here? I get, so this is 39 minus 6 minus 5. F of 13 is, I want to say it is 6 minus f of 2, which is 1. So this gives us 33 minus 25, or 8. Okay, looks good. Let's continue. I'm going to grab that table because I am running out of space and I can't see. Let's grab that table. Okay, so for letter C, we're supposed to use Riemann sum, a Riemann sum with subintervals indicated by the data on the table to approximate the integral from 2 to 13 of f of x d of x. Okay, and of course we're going to show our work. So we want to figure out what is this. And I'm using the data in the table to approximate. I'm using left-hand side Riemann sum. So remember what that means is I'm using left-hand side rectangles. Okay, so let's go and do that. So for the first rectangle has a base that stretches from 2 to 3, right? So I'm going to find that stretch, and then I'm going to be using the height. In this case, the height of that rectangle is 1, because again, I'm using the left-hand side of that rectangle. To that, I'm going to add the next one. So again, let's just kind of really quickly. I found the rectangle using these two, right? So I said the base of the rectangle is 3 minus 2, right, or 1. And the height of that rectangle, because I'm using left-hand side, is 1. Now let's move on to the next one. So now the base of this next rectangle is going to be, whoops, I'm doing this in finger paints. It's going to be 5 minus 3, right? That's going to be the base, and the height, again, is using the left-hand side, so that is 4. And let's continue. From there, I'm going to go from, looks like I'm going to go from these two. So now the base is going to be 8 minus 5, and the height is going to be left-hand side, which is negative 2. And then last one, I'm going to be doing these two. So the base is 13 minus 8, and the height is the left-hand side, which is 3. If you add and subtract and do all that good stuff, you add all those things together, you will get 18. So that is our approximate value. Let's go on. I'm going to grab letter D and move it down here. And I'm going to, I wonder if I'm going to need that table. I don't know if I'm going to need that table or not. I don't think I do. Don't think I do. Okay, what do we got? Let's get rid of this thing right here. Okay, suppose f prime of 5 equals 3. So the slope of the tangent line at x equals 5 is 3. And the second derivative is negative, which means this function is concave down on the closed interval from 5 to 8. So this thing's concave down on the closed interval from 5 to 8. Use the tangent line to the graph of f at x equals 5. So we're going to have to, I'm going to start right there because there's a direction. I'm going to have to find the tangent line at x equals 5. So in order to find the tangent line, right, in order to write the equation of a line, I need two things. I need a point and a slope. Well, they were very nice in giving us the slope, right? Since f prime of 5 equals 3, that's our slope. And the other thing I'm going to need to know is the point. Well, it passes through the point 5, going to my table, negative 2. So 5, negative 2. So let's write the equation of our line. So we get y plus 2 equals 3 times x minus 5. I'm going to solve this for y for no good reason. They didn't ask us to, but I'm going to do it anyway. So I get y equals 3, x minus 5, minus 2. Okay, there's the equation of my tangent line. What do they want to do now? So use the line tangent to the graph at x equals 5 to show that f of 7 is less than or equal to 4. Okay, so let's take, I'm going to evaluate my line and I'm going to see what it comes up with. So let's see, I'm going to take y, I'm going to take the function, I'm going to evaluate x when x equals 7. So I get 3, 7 minus 5 minus 2. This is going to be 3 times 2, which is 6, minus 2, which is 4. So in other words, y of 7 equals 4. Okay, now we know that y equals 7 equals 4, but how do we know that it's less than that and not greater than that? Well, that's where the concavity is really important. We were told that this function is concave down. What does that mean? That means that any tangent line on the interval from 5 to 8 will lie above the graph. Therefore, since it's going to lie above the graph, right, the largest value, since we evaluated the line at x equals 7 to be 4, the largest value that we can possibly get for the function is that number 4. Okay, so let's put that into a nice, let's write that down. So, first off, let's think about what I talked about. So things we have to mention. We have to mention concavity. So I'm going to say since f double prime is less than 0, the function f is concave down on the given interval. Okay? Which means the graph, right? The graph lies below any tangent line in that or on that. Let's just say in that interval. Okay? So what have I established so far? I've established, one, that I've said, hey, look, the function's concave down. Then I've said any tangent line, right, lies above because the graph lies below any tangent line. So the tangent line is above. So now I can say, since the tangent line approximation gives approximation at x equals 7 is 4, the, let's see, f of 4, let's call f of 4, must be less than or equal to that number. Okay? So again, the big thing from here, what do I have to establish for the big thing? The big thing from here that I have to establish is 1, the function was concave down, and 2, that means the tangent line that I evaluated at 7, right, is above the graph. So the graph can have at most f of 7, not f of 4. I see that. I see it. I'm fixing it. F of 7 at most can be 4, but it can't be greater than that, right? It has to be less than or equal to. Okay, that is part 1. Let's do the second part on that. What do we got? So second part, what is it asking? Use the secant line for the graph from on that interval to show that f of 7 is greater than or equal to 4/3. Okay, so they're asking for a secant line. So in order to find the secant line is right, the line that passes through 2 points. And the points were from 5 to 8. So it's going to pass through 5 something and 8 something. So according to our table, that is 5, -2. And 8, +3. Okay, let's write the equation of the secant line. So the slope, I think you guys would agree, the slope is going to be 3 + 2 over 8 - 5, which is +5/3. Writing the equation of the line, I'm going to grab, doesn't matter, I'm going to grab the first point. So I'm going to say y + 2 = 5/3, x - 5, and then solving for y, I'm going to get y equals 5/3 x - 5 - 2. Now, there's my secant line. I'm now going to evaluate the secant line at, what did they ask me to evaluate it at? Show that f of 7 is greater than or equal to 4/3. So I'm now going to evaluate the secant line at 7, right? And let's see what we get. So I get 7 - 5 - 2, which is going to be 5/3. 7 - 5 is 2, so that's 10/3 - 2, which is 4/3. Okay, so we know that the line that we created, right, at 7 is 4/3. Now we have to determine, is it above it or below it? So let's think about this for a second. Okay, So we have this graph, and it is concave down, right? Here it is. It's concave down from this endpoint at x equals 5 to this endpoint at x equals 3. We have drawn a secant line through those 2 points. Notice, because it is concave down, that line has to be below the function, which means f of 7 has to be greater than or equal to, right, the value that we just found. Okay, so that looks good. Let's see if we can write that down in a way that makes sense. So, since f is concave down, again, I'm talking about it being concave down, the secant line from, let's say, from 3 to 5, was it closed or open? I don't know if it mattered. I think it was closed. I'll double check. I will double check. Yep, from 5 to 8, excuse me. So from 5 to 8 lies below the function on that interval. Therefore, I'm going to write this by hand because it's a little harder to type it. So I'm going to say, therefore, f of 7 has to be greater than or equal to 4/3, right? Because the secant line lies below the curve. Okay? Well, that is what we got for problem number, what is it? Problem number 23. That's problem number 23 for you. So as always, make sure you do not like, comment, or subscribe, and I will talk to you later.